Welcome to Module 3. This module focuses on brute force and dictionary attacks. These types of attacks are the easiest form of targeting web applications. They consist of checking all possible rule-based or dictionary combinations of logins and passwords. Cracking the password may not take a lot of time, so in practice, these types of attacks are often unsuccessful. The HTTP auth scheme is the first authorization method that may be exploited for attack. It is implemented in all web browsers, and virtually all web servers enable setting it in an easy way. Here, we'll talk of HTTP auth implemented in the Apache web server. The core of this scheme is htaccess, a file used for many purposes, including HTTP authorization. If you store it in a directory accessed by a web server, all the files contained in the directory will become protected with the user ID and password. You may specify the message which will be seen by users and indicate the file containing passwords used for authorization. Let's now try to create such a file. In Apache, the command htpasswd is used for this purpose. Here you may see the syntax for calling the command. To create a file containing passwords, you must first enter the name of the target file. It's good to mention that files with the extension htpasswd and htaccess are protected by the web server by default and may not be accessed by users. Regardless of this, it's better to put files outside the document tree of the web server. Next, we enter the username and password. Our password here is 1234. The file has been created. Now let's see how this works in practice. We'll use the Live HTTP Headers add-on. The extension allows us to view the live communication between browser and server. As we can see, the web server has a set special header, www authenticate, instructing the browser to authorize the user. First, we'll enter an incorrect password. As we can see, the browser encodes the login and password with a base 64 scheme, and a special HTTP header is set. The server decodes the string and compares it against data stored in htaccess. Let's now submit the correct login and password. As we can see, this time the authorization is successful. Browsers remember requests for authorization and the provided data. The information is transported automatically with each attempt to access protected resources. Because of this, no further authorization will be needed. Let's now try to launch an attack targeted at this authorization scheme. To do this, we'll use Hydra, an application that enables dictionary attacking a variety of utilities, including the HTTP auth scheme and web forms. We can see here the description of parameters of calling Hydra. For the parameter L, let's submit the file containing a list of usernames. Let's see what these dictionaries look like. They are simply a list of words which may constitute usernames or possible passwords. We can also see that the files include our login and password. Next, we submit the file containing the passwords dictionary. We also need to submit the address of the web server which will be analyzed and the name of the attack. Next, as a method parameter, we submit the path to resources which require such authorization. Let's now try to start the command. As we can see, the sample attack has been successful. One service has been targeted, 21 login and password combinations, and also our access information have been found. It may be worth it to take note of another authorization scheme. It's a simple login form created in the PHP language. It is displayed by default. If a user submits the form to script, the provided data are compared against the data held by the corresponding variables. To log in, the user must type the username admin and the password root. Let's now see in practice how the scheme is working. Submitting incorrect login and password will cause the message error to be displayed. If the correct information is given, the message logged in may be seen. Now we'll find out how Hydra may be used to launch an experimental attack on the form. Indicate dictionaries which will be analyzed by the application. The dictionaries include the correct login and password to our script, so the attempt should be successful. Here, the server name must also be given. This method is called HTTP post form, as the form is passed via the post method. Method parameters are the form's address, data string, and the message displayed with each failed login attempt. Provide the string representing the encoded form after the colon. The value user is changed to logins selected by the application. While pass is similarly changed to checked passwords. We also need to pass the field, Go field, which is used for logging in. Enter the message displayed with the failed login attempt after the second colon. Let's see how this command will work. As we can see, the attack has been successful. The login and password combination has been found. The demonstrated examples used ready-made dictionaries. Let's think what could be done if we didn't have access to such lists, or if for some reason they remain ineffective. The solution is John the Ripper, a password cracker which also enables the generating of password strings for brute force types of attacks. The John MMX version is faster as it utilizes special processor instructions. While it may be quite aged, the application is still fully functional. As we can see, the command may be executed in different modes. We're interested in the incremental mode, which generates character and digit strings. This may prove useful in brute force types of attacks. The incremental mode assumes the parameter mode, which defines character sets used to generate new passwords. Let's start with the standard set digits. You must add the parameter stdout to write the generated passwords to standard output. Alphanumeric characters is the second mode. Another is all, a mode for generating passwords from all characters. Generated passwords are passed to a standard output, although they may be redirected to a file to generate a dictionary. The dictionary may in turn be used as a parameter of calling Hydra. As we can see, the file has been created. So how can we protect ourselves against these threats? The first and most significant solution is to force users to use strong passwords. The stronger the password, the more time a brute force attacker will need to check all possible combinations of characters. Passwords should not use words listed in popular dictionaries. It may often be worthwhile to introduce a scheme for blocking a user session after a limit of failed login attempts is reached. We must remember, however, not to provoke an account lockout, a situation which occurs when users are locked out of their accounts. We'll talk more about this in the next module. That's all for now. Thanks for your attention, and see you in the next module.